Welcome back everyone to the series where we are discussing the solutions of the activity questions. So we were discussing activity 1.1 and we have discussed the first 5 questions of the activity. Now in this video we will be discussing questions 6, 7 and 8. So let's get started. So here we have question 6 with us. In the question 6 we know that A and B are two vectors and which of the following statements are true. So let's start with analyzing the option first. We analyze the right hand side of the option first. We are given 3 times of A plus B plus A plus B minus of A minus B. We want to simplify this expression. So here 3 times of A plus B is going to be 3 times of A plus 3 times of B plus here we have A plus B. Now minus A minus B is going to be minus A plus B minus A plus B. So here we know 3A plus 3B will remain the same, 3A plus 3B plus. Here if we see we have plus A minus A, so they will cancel out each other and we have B plus B, that would become 2B. So this expression would become 3A plus 5B. So let's check whether the first option is correct or not. Yes, it is correct. Now, let's analyze the option 2. In option 2, we have 5A plus B minus of A plus B minus of A minus B. It's 5A plus B minus of A plus B minus A minus B. So first, 5A plus B is going to become 5A plus 5B minus of, if we simplify this term, this is going to become A plus B. Okay, minus, it will become minus A plus B. Okay, now 5A plus 5B minus of C. We have plus A minus A, they will cancel out each other, and we have plus 2B. We have minus sign here as well, so it would become minus 2B. So overall, this thing would become 5A plus 3B. So 5A plus 3B is the correct simplification of the expression. And here in the option, we are given 3A plus 5B, which is incorrect. Okay, moving on to the option third. In the option third, we have 3 times of A plus B. So let's write it here. We have 3 times of A plus B and plus of A plus B plus A minus B. Now, if we try to solve this, we are going to get 3A plus 3B plus. Here we have A plus B plus A minus B. A plus B plus A minus B. So again, plus B and minus B will cancel out each other and we'd be left with 2A. So here we have 3A plus 3B plus 2A. So if we add the terms of A, it would become 3A plus 2A, 5A plus 3B. So if we check the option, it is 3A plus 5B, which is incorrect. And moving on to the option 4, we have 5 times of A plus B. Yep. Something plus or minus. Yeah, it's minus. A plus B plus A minus B. So it's just A plus B plus of A minus B. So we have just simplified this term, which was coming out to be 2A. So we can directly write it as 2 minus of 2A. We have 5A plus 5B. So 5A minus 2A will give you 3A plus 5b. So let's check whether it is correct or not. Yes, 3a plus 5b is correct. So in the question 6, we have seen that option 1 and option 4 are correct. Rest of the options are incorrect. Moving on to the question 7. In the question 7, we are given vector v1 as 1, 0, 0, v2 as 0, 1, 0, and v3 as 0, 0, 1. Now, a, b, c are three real numbers. They are scalars. Which of the following options are true? So, analyzing the RHS of the first option, we have a times v1 plus b times v2 plus c times v3. So now we are used to these things. We can directly write it as a times 1, 0, 0 plus b times 0, 1, 0 plus c times 0, 0, 1. So it would become a, 0, 0 plus 0, okay, let me write it, a, 0, 0 plus 0, b, 0 plus 0, 0, c. So now if we do the vector addition, it would become a, b, c. So here we can repeat the same process for rest of the options as well, but because we are solving mathematics, so let's try to do some observations. Let's try to observe few things. Here we know in V1 we just have the first component is 1 and rest of the components are 0. So it means if we multiply any constant with V1, the constant would appear in the first place, whereas all the other terms would be 0. Similarly, in the V2, if we multiply any constant, it would appear in the second place, whereas the first component and the third component would be 0. And in V3, the first two components are going to be 0, whereas if you multiply V3 with any constant, then the constant term would appear in the last position, that is your third component. So here see, we have AB times V1. So we saw anything, any scalar multiplied with V1, it would appear in the first position. So AB times V1 is going to be AB, 0, 0. Now plus BC times V2. So BC times V2, in V2 we saw the change would get reflected in the second component and rest of the components will remain 0. Plus CA times V3. So plus 0, 0, V3. In V3 we saw the change would be reflected only in the last term. So overall, if we take the vector addition, it would be AB, BC, CA. Now, if we again observe few things here, so we can see that okay, if we are multiplying something with the V1 here, it is going to appear in the first place. Okay, if you multiply something with the V2, it is going to appear in the second place, and if you multiply something with the V3, it is going to appear in the third place, because we have such a nice pair of vectors 1, 0, 0 plus 0, 1, 0 plus 0, 0, 1. So now if we just look at the next option, that is A times V1 plus C times V2 plus 0 V3. A times V1 plus C times V2 plus 0 V3. So if we directly try to write the answer for it, we know A times V1, so this A will appear in the first place, C times V2, so the C will appear in the second place, 0 times V3 means this 0 will appear in the third place. So overall it would become ACO. Okay. Keep in mind that it is happening just because we have such a nice pair of vectors, which is 1, 0, 0, 0, 1, 0, and 0, 0, 1. Now, similarly, if we analyze option 4, we have A, V1 plus 0, V2 plus CV3. See, at any moment, if you are finding this as a bit confusing, you can go to the steps of option 1 and you can solve all the steps like this, right? It's just a way we are trying to take a shortcut here. So A will appear in the first place because it is a coefficient of your V1 basically. 0 will appear in the second place because it's the coefficient of your V2, and C, because it is getting multiplied with V3, it will appear in the third place. So A times V1 plus 0 times V2 plus C times V3 is going to be A0C. So A0C. So option 4 is correct. It's option 3 was incorrect. Option B was incorrect. And option 1 was correct. So this was the solution of your question 4. Now moving on to the question 7. Sorry. Now moving on to the question 8. We have vectors A and B. So A is minus 1 comma 2. We can locate it here. And B is 2 comma minus 2, which could be located here. One thing we can observe that V2 is in the direction of A, whereas V5 is in the direction of B. So when we know about the direction of when we know that two vectors are in the direction of each other, we can write just one thing, that V2 could be written as the scalar multiplication of A with some constant. Why? Because whenever you do the scalar multiplication, you just change the magnitude of the vector. So if A is in the direction of minus 1 comma 2, if A is in this direction, so if V2 is in the same direction, in the same line, that means you can write V2 as K into A. Saying the same line would be more appropriate because even if the V2 is just in the opposite direction of A, you can still write V2 as equal to K times A, where K is some constant. If it is in the opposite direction, K would be negative. If it is in the same direction, K would be positive. So I shall write that K belongs to some real number, K is some scalar. Similarly, I can write for V5 as well, that V5 is also some, we have used K, so let's use M this time, some M times vector B, whereas M is also some scalar. This was the information that we could extract from the given diagram. Now let's move on to the question. So here we have to choose the correct set of options. The first option is V1 represents a scalar multiple of A. So we can see that V1 is not in the direction of A. The direction is different. So because the directions are different, and so this is incorrect. Whereas in V2 we saw that V2 is in the same line of A. Okay, so that means V2 could be written as some constant scalar multiplied with A. So V2 is option 2 is correct. Similarly, we have seen the same thing for V5 as well, that V5 could be written as B multiplied with some scalar. So it is also correct. Now this option is incorrect as well because V1 is not in the line of B. Now coming to option number 5. Here we are given that V4 represents a scalar multiple of A plus B. See, first of all, what A plus B is. So we know that A is basically minus 1 comma 2, whereas your B is 2 comma minus 2. So if we talk about A plus B, that is going to be minus 1 plus 2 comma 2, which would give us 1 comma 0. So we know that this vector A plus B, let me write it as C. So there is some other vector C that is given as A plus B. So this vector is equal to 1 comma 0. That means 1 comma 0 is a point that lies on x-axis. So any scalar multiple of 1 comma 0 would lie on x-axis. So if I want to write any vector, let's say Vi, that could be written as k times of 1 comma 0, that is k times of A plus B, For that, I can conclude that Vi lies on the x-axis. If this is given to me, then I can conclude that Vi lies on the x-axis. Now, any vector that lies on x-axis can be written as scalar multiple of a plus b. So let's check. V4 lies on the x-axis, means it could be written as scalar multiple of a plus b, but uh, V3 or let's say V5 or V1 or V2, these vectors do not lie on x-axis, so they could not be written as a scalar multiple of a plus b. This option is incorrect, whereas this one is correct. Now, there could be some confusion when people say that it could be represented as a linear combination of A plus B, a linear combination of A and B. So, linear combination of A and B would mean, uh, uh, let's write that in the different page. It's just the terminology, the difference in the terminology. If someone says a linear combination of A and B, this means the person is talking about some a constant x times a plus some constant y times capital B, whereas your xy belongs to some real number. Okay, so this is completely different from what we say the scalar multiple of a plus b. Scalar multiple of a plus b. That would actually be uh, k times a plus b. Now moving back to the options, yeah. So we can see that option 1 was incorrect, 2, 3 were correct, then again 4 was incorrect, 5 was correct, and the last option was incorrect as well. So these were the solutions for the questions that we discussed in this video. So in this video, we discussed question 6, 7, and 8. So thank you so much and see you in the next video.